Hey guys, Mr. Backward here. In this video, we're going to look at graphing the derivative from data. So as we're looking at a set of data points, one thing that we could do is create a scatter plot, and then from a scatter plot, we could use regression to help us come up with an equation that would help us represent those data points. And then from that equation, we could go ahead and do the derivative of whatever function we end up with. But there is another way that we could look at using data points to help us come up with a derivative. So in this example, we're going to look at the probability of having a shared birthday depending on the number of people that you have in a room. So if you've got a room of 30 people, then the probability that there would be a shared birthday among the people in the room would be about 0.706, or about 70.6%. So if we assume that no one day is more likely to be a birthday than any other, then we can come up with the probabilities shown in this table below. So if there are 0 people in your room, then there would be a 0 probability. If there are 5 people, then that would be 0.027, or 2.7%. Jump up to 10 people, and it's 0.117, and so on down the line until we get all the way down to a room of 70 people, where the probability is 0.999, or almost 100%. Now, like I mentioned before, from these data points, we could come up with a scatter plot and then run some regression techniques to help us figure out a function to represent this data, and then using that function, we could find its derivative. But there's also another way that we could go about this. So we've got our data, and here's a scatter plot that's going to represent all of this data. Now, taking a look at this scatter plot, we can see that towards the beginning, the probabilities increased faster, and then as we get further towards the end, the probabilities didn't increase by as much. But let's say we wanted to figure out where they were growing the fastest. And one thing that we could do there is use the derivative to help us figure that out. Because if we're looking for where it's growing the fastest, we're looking for where it's going up the quickest, that's really the slope of a line. So we're looking for where the biggest slope is on this graph, because that's going to represent the steepest growth. And we know that slope is one way that we can think about a derivative. So what we're going to do is start building a new table. For the y values in the table, we're going to look at the slope between consecutive points. So to start with, we would look at the 0, 0 point and the 5.027 point, and we would find the slope there. As far as the x value, we're going to use the midpoint between these two x values that we started with. So for the first ordered pair, if we took the midpoint of the x's halfway between 0 and 5, that would be 2.5. And then if we found the slope between these first two consecutive points, so y2 minus y1, over x2 minus x1, we would get a slope of 0.0054. And we can do that all the way down the line to create this new table of data. Now, if we're looking for where the probability was increasing the fastest, remember we said we were looking for the highest slope. So if we look right here at these 2 points, at an x value of 17.5 and at an x value of 22.5, the slope there was 0.0316. And it's the same for both of those. And looking at all of those y values on the table, those are the two biggest y values. If we look at this graphically, a scatter plot of this new table that we could come up with, the highest points on there are those 2 points that we just talked about. That's where our original function has the highest slope, because remember, these data points were found by using the slopes between consecutive points. So if we're looking at what's happening, we're increasing pretty rapidly at first, and then we reach this highest point. Now we've got kind of 2 consecutive points, so I would assume that this graph rounds off about halfway in between here and then starts heading down. So we said that this was happening between the x values of 17.5 and 22.5. So we could estimate at an x value of about 20, that would be the highest point on this graph. So that would be the highest slope. So from that, we could estimate that when you've got a room full of 20 people, that's where the probability jumps the most between those consecutive values. That's going to be it for this video. Thanks for watching.